Okay, today I'm going to talk about the solutions of assignment 2. So let's look at the first questions, the part A of the first question. The known condition of the question is a random sample that obeys a normal distribution with a population mean of mu and population variance of 4. First, we need to find the estimator of theta. Estimating theta is the same as estimating the mu's power of e minus 1. And since there is only one unknown parameter mu, we can only need to estimate mu. So how do we estimate mu? Here, we can use the weak law of large numbers and think of the sample mean as an estimate of the population mean. And then we can get an estimator for theta. Next, with respect to the second question, we need to consider how to get a 96% confidence interval for the parameter theta. Here, we can use the central limit theorem and the delta method to attempt the asymptotic variance by constructing a function whose first-order derivatives exists and is not zero. And then we can attempt a random variable that obeys a standard normal distribution that contains theta, like this. Next, this random variable obeying the standard normal distribution is placed in the interval minor z 0.02 to z 0.02, and a 96 confidence interval for theta can be obtained by simplifying both sides of the inequality separately. This is the first question. And let's look at the part B of the first questions. Again, he wants us to find a confidence interval for the parameter theta. And the difference is that this time the random sample obeys a normal distribution in which the population variance is unknown, right? So as well as the expression for theta contains an unknown variance. Therefore, we cannot imitate the first questions to construct a function and get a confidence interval, which implies that we need to find something about the distribution of the variance. So in this section, we need to introduce the chi-square distribution to get a random variable containing the sample variance and the population variance, obeying a chi-square distribution with n-1 degrees of freedom. And this n-1 degrees freedom chi-square distribution also tends to a normal distribution when n is large enough, here like this. And then next, by simplifying, we can get that the sample variance S squared obeys the following normal distribution. Then, by using the delta method, we can attempt that a random variable containing the parameter theta obeys a standard normal distribution like this, whereupon the confidence interval for theta can be attempted by simplifying the interval like this, just simplifying the both sides of the inequality separately, and we can get the 96% confidence interval for theta. Then let's look at the second problem. In this problem, a random sample xi, which obeys a normal distribution, with an unknown population mean, mu, and a random variable, yi, here. That depends on the value of xi. We know these two conditions. And we need to find the likelihood function and the MLE for the parameter theta. First, we need to analyze the random variable yi, which is apparently a Bernoulli random variable. And then we have the probability that yi equal to 1 is equal to the probability that xi is greater than 1. The probability that yi equal to minus 1 is equal to the probability that xi is less than or equal to 0. Then we just set the first probability be phi mu and the second probability be 1 minus phi mu. Then, based on the known 10 sample data, 4 positive and 6 non-positive data in the sample, we can get the likelihood function corresponding to the samples. And then, based on the expression of theta, we can get the likelihood function of theta like this. Then, by finding the value of theta with the first order derivative equal to 0, and by checking that the second order derivatives are less than 0, we can get the MLE of theta is equal to 0.4. Next, the MLE of mu can be obtained by solving such an equation like this and checking the corresponding standard normal tables. Then let's look at the question 3. In this question, it's easy to see that x is a discrete random variable, and we can quickly derive the corresponding population mean, Ex, and the population variance, VARX. Next, to show that the estimator of theta converges in probability to theta, we can get the proof by jointly using the weak law of large number and the continuous mapping theorem. In order to get the confidence interval of theta, we first look at the known condition. According to the provided data, we can get the sample mean is equal to 1.4. And by the numerical substitution, we can get the estimator of theta is approximately equal to 0.571. Then, by using central limit theorem and delta method and construct a function, we can get the asymptotic variance is equal to 0.25. And then, by simplification, we can get the theta confidence interval like that. Last questions. Regarding the confidence interval attempt above, there are maybe two problems. On the one hand, the guess interval may be too wide because of the limited data. Yes, just 10 data, right? So it needs the larger sample to improve its precision. And on the other hand, the estimator may have bias in the small sample size. Okay, the above information is all the three problems. Yes, so let's finish the class.